Thank you very much. It's a huge pleasure to be here, so thank you very much for having me and us. Just to introduce myself very quickly, I'm currently at Microsoft in France, running some of the startup programs that we have there. I used to be the person who covered the French market for TechCrunch, so I inevitably find myself moderating random panels every now and then. So this will be one of them. We're going to discuss big data. We have some terrific speakers with us. So I will let each of you present yourself very quickly. Michael, you're at Pivotal. Do you want to tell us a little bit about, and I think you actually went to Cambridge, so I'll throw that in there.
I went to Cambridge for my sins, yes, but not this college, I'm afraid. I did a PhD in theoretical physics at Trinity, but that's already a long, long time ago, hence all the grey hair. I now work at Pivotal. How long do you want the introduction to be? Mini introduction?
As long as you'd like.
Oh
Share
dear, that's bad, guys.
Let's do two essentials.
No, thank you. So I now work at a company called Pivotal. We're a startup. But we're a strange startup. We're actually a spin-off out of a much larger company, out of EMC. And EMC has kind of gathered all their sort of next generation data assets and put that into our startup. So there's about 1,000 people of us, mostly on the West Coast, but also some sort of enclaves, reverse pilgrims here in Europe. And what we're supposed to bring is really bring the value of data to our customers. And the question is, so what is that really, that value of data? And I'm intentionally not using the term big data, which of course I've just done. So the value of data, if you think about it, data has extremely high value at very short time spans. So in near real time, microseconds, nanoseconds, not yet nanoseconds, microseconds, high frequency traders like that. Milliseconds, the banks and the telcos like that, because they can optimize quality of service in the network or do a fraud check on transactions. So in very short time spans, near real time, the value of data is very high. But you also need, at the other extreme, at the very long time scales, you need large data sets to be able to run the long run statistics and to do all the clever things that we do in Pivotal around machine learning. That you need to apply to very large data sets to understand what are the patterns underlying the kind of behaviors that you're trying to understand, the deviations from those patterns. For that, you need big, long-term data sets. And what we're trying to bring to the market is the combination of those two. So we have assets that help make decisions in real time or near real time, whatever real time actually is, based on the understanding that we get from data in the longer run through the large data sets. So decisions fed by the machine learning out of long models.
And what is your role within the company?
So I had the European data science team, and my role specifically, or our role in the data science team, is to bring the machine learning to our data assets.
Great, thank you very much. And now, if I'm not mistaken, Ulrich, you're also a Cambridge.
I used to be in Cambridge for many years. I did my PhD in particle physics in Kerzel in Germany, and then came to Cambridge as a postdoc and stayed here for like 6 years or so. In the end, was a senior research fellow at Modern College, and then got a research fellowship at CERN before then leaving science and returned to my PhD supervisor, who founded the company I work for now about 6-7 years ago.
So Blue Yonder, tell us about what you do there and what the company does.
Blue Yonder was originally founded as a spin-off from the University of Karlsruhe, back then as named as FIT for Physics Information Technologies, which isn't really market compatible because FIT gets to pronounce fit and all the other things. What we do is, no surprise, I guess, the big data and predictive analytics, machine learning, so we focus on this data science as well. And it got rebranded to Blue Yonder. So what we do is take the data from our customers and try to gain insights what will happen in the future. The future can be like a day, it can be a month, it can be half a year, it can be a year. And typical things we work on now, for example, in retail sales forecast, how many apples will be sold on any given day in any given branch of a supermarket, or in fashion industry, what will be sold in, how many shirts and of which color will be sold next season. We also do financial work in what was the optimal insurance tariff, how would you predict the cost of any members in a private health insurance. FIT has also used the machine learning techniques for quite a year to run a hedge fund, so there's quite a wide applicability of what you can do with the big data.
All right, thank you. And Michael.
Correctly, someone on the stage has a mobile device that's on. It has to be completely off.
No, I don't.
No, I put mine.
Mine is off, but you can take it so I can. So,
Do you want to take my bag?
Don't move.
I'm going to continue like this, no? All right. Okay, I'll leave it here. All right, and can everybody hear when the other speakers speak? I'm worried that we might not be speaking into the microphones enough, so if we could just be sure of that. I'm scared not to move. Michael, and I have 2 Cambridge grads here.
and I'm Gerald.
I'm sorry, Gerald.
But that's okay, I could be
Confusing
Mike, if it helps.
We'll switch it all. I'll call everybody by different names today. Gerald, and from Bloomberg, tell us what you do there and what you did prior.
Yes, okay, so Bloomberg, we're a financial information company, and I've been there about 26, 27 years, and I guess the relevance to big data is, I guess we do it in a practical sense. As may come out in today's conversation, I'm a little bit cynical because it seems that most of the time big data is a way you can part people from their money quicker, and especially CEOs and other people who should know better. But we absolutely believe in practical big data and applications of it, and how do you actually help people manage information and give them insight into things that they wouldn't have had before. I was with Bloomberg's, we have a fund which is investing in early stage businesses, actually quite focused on big data and visualization and trying to find insight. Up until 2 days ago, I'm now Chief Operating Officer of our core business, but I still care about it from a point of view of how do you manage a business, but also what do we sell.
Great. So Gerald has actually already kicked us off on a topic that I wanted to discuss, which is what is big data, and is it kind of a fluffy name for nothing? Sorry to ask a very controversial question for our panelists that are passionate about the topic. Why don't I start with just a definition of what is big data? I'm sure a lot of people here know. We kind of just spoke about it, the previous speaker. But just to give us a definition, what are we calling big data today? Ulrich, I'll start with you.
Well, as you say, I guess the big data has a different meaning for everyone. So as we're particle physicists, as our background, big data for us means what comes out at CERN, which turns out to be 1 petabyte a second of data coming from an experiment. So this is where we come from, what we call big data. In industry, it really amounts to different things. It not necessarily is connected to the sheer volume of data, but you draw it back together different sources of data, different types of data. You no longer store something in like a database like write once, never read. You try to combine different data sets, correlating to what you say to draw insights to what you want to do in the future. And that can be quite specific. If you are in finance, big data will have a different meaning to you. If you are in retail, you will focus on different aspects of data.
And Michael, you agree with this?
Yes, I think yes, and I think we probably can agree with amongst us friends that we probably don't really like the term big data anyway.
Why? What's wrong with calling it big data?
It means it's everything and nothing is implied in the term big data. I want to pick up on something that JP said during his keynote. I shall start by saying that I love and adore JP, and I had the great fortune of knowing him for a number of years. But I do sort of violently disagree with something that he said in his otherwise excellent keynote, and that is that it's all about the rows. So what he's saying is that if you look at data and you look at a table, then it's big data is about more rows and it's not about columns. And I think I have a couple of points around that I don't feel particularly comfortable with that description. So first of all, yes, there are the rows, which is what Ulrich just mentioned. It's about the volume, it's about the petabytes per second or whatever it is that you amass. But it's also about the complexity, which is sort of the columns argument. But I think more fundamental beyond that is what he's so eloquently described there is sort of the old-fashioned world of the relational database. We've moved, over the last 2 years, we've moved way beyond that. And what actually drives a lot of the understanding that we can get out of the kind of data assets that we are surrounded with now comes from unstructured data. So, and that doesn't fit neatly into any kind of row and column picture because it doesn't fit into a relational database model. And therefore, a lot of the insights that we're going to gain do not fit the kind of row versus column description anyway, because you have a completely different set of data assets that you want to understand, that you want to get a head around, make sense of, and predict on. So I think big data is the sort of the rose argument. It is the complexity argument, but more on top of that, it is the nature of data has actually changed, and what we can now reason over has vastly improved as a result of the increased computing power and as a result of the vastly increased mathematical techniques that we have at our fingertips now. We can make much better sense of data that in the past we just had to discard.
Gerald, I know you take a bit of a more cynical approach to big data.
Well, I guess the definition is probably important here, because I guess let's look at three almost equivalent data rates. A studio video camera will put out about 1.5 gigabits per second of raw video. The Chicago exchanges put out about the same. The Twitter feed is about 10th that. The amount, if you have a studio camera in the East End set, a set of East Enders, I'd imagine the information content of that 1.5 gigabytes is near zero. Whereas, the Twitter feed, maybe it's a bit more than that, and then from the Chicago exchange, from the options exchange, maybe there's some content in that. So you've got to kind of define what you're talking about. And other ways, or getting big data around. I think still the fastest way you can ship big data across London is in a truck with a full of hard drives, faster than any kind of existing technologies. But it's really about, I guess, it's always about refining what we've got. Can we understand what we've got? And we're always at the cusp of what we can just about do. Throughout history, whether it was the Japanese rice traders taking a data set and putting it into a candle chart, or what we do now by taking maybe an unstructured set and putting it into a system that tries to look for anomalies or interesting things that we can then do something with. We're always on the cusp of what we can do, and we'll be extending it. And therefore, to say that now is something special in big data is, I'm not sure it has a value apart from shifting product, which I went back to.
Great. And I actually saw a Wired article not too long ago that was titled, "More Data, More Problems." And essentially the article's argument was that we are becoming so data-driven and we are just focusing on that, and there's a number of dangers associated with it. Do you feel the same way? Ulrich, I'll ask you, what are the dangers associated with big data?
The dangers of big data. Well, I guess it's a lot of what you do with it. If you read the press recently, you will be aware of what you can do. A lot of things with correlating information about people. So if you are in a business environment, there you need to be aware of where you want to go. You need to be aware of that you can now really pinpoint to what people do. Maybe an anecdote to that: there's a large US supermarket chain where they used all their sales data and started individualized couponing and sending out coupons. And they did that to a family, and the dad would receive all the coupons, and then he had an underage daughter, and he started receiving all these pregnancy coupons for products related to that. And then I said, angry, called the store, and then I said, look, why are you sending me all of these garbage? Clearly you have no need for that. And I said, Daddy, there is something I need to tell you. So clearly there's a point to be made. So just because you have data, you also need to be aware now that you correlate more and more information. How far do you want to take it? What do you want to do with it? In particular, what do you want to achieve with it in your business environment?
Michael, do you have additional risks associated with big data?
So the reason, I think the reason why we're excited around sort of having huge data assets at our disposal and having the techniques to be able to make sense of them is because that enables us to make better decisions. So in the past, we had to have some sort of, the company executives, people who led organizations, people who had to make decisions based on their experience. And that worked well for a long time when things didn't change very fast and experience actually mattered a lot. These days, things tend to change very fast, and experience is starting to take a sort of a second place compared to being able to make decisions based on data. So the fast-changing environment and our understanding of data enables us to make better decisions. The problem comes if you go the other way and you make decisions entirely based on data and entirely based on statistical analysis. Realistic decision-making and good decision-making still needs to have some sort of human, soft and fluffy experience-based component to it to be actually be a good decision at the end of the day. But I think the great advancement forward that we have now is we are able to much easier than ever before take real data and analysis into account when we want to make decisions. But it's important not to go the other way.
Well, that's an interesting statement, though, because I feel almost that we are more inclined to trust data because it's neutral.
Yes, that is true. I think my favorite example on that comes back to the one of the movies that sort of popularized our field, and it's Moneyball. Seen Moneyball? Not. You need to see Moneyball. It's a great movie. Okay, it has Brad Pitt in it. There's a downside, but it's actually a great movie. And the book is, if you don't like movies, the book is actually quite good as well. But what the movie is about this baseball team that uses statistics to select players that are undervalued but actually score very well, and to therefore change the way in which that baseball team changes its players based on statistics. And you walk out of the movie or walk away from the book kind of believing that, so statistics now rules the world and the way we make decisions has changed completely. But in reality, even the baseball players' selection still takes into account the experience of the people who select the players. And I think in reality what we see is that you still need to fall back onto your experience base. And the better decisions are made when you take the whole spectrum of human experiences into account, because a player may have great statistics, or in that example you choose two players with the same statistics, but one of them they after their exercise or whatever people do on a baseball field, they go home and spend some quiet time at home, versus the other guy who goes out partying all night. And probably as a baseball player selector, I suspect you would want to choose the quiet guy who's not going to wear himself out through whatever activities. So there's a set of what it comes down to. There's some information still that is not necessarily quantifiable, and if you only look at information that is available in a quantified manner, then you're going to miss out on the whole spectrum of information that you need to make good decisions.
Gerald, do you agree?
I think so. I guess if you cast your mind back about 4 or 5 years, in the 90s, the Bank of International Settlements put out something called best practice about how banks should look at their risk. And in the early 2000s, you had lots of organizations who are running large computer centers doing cross-correlations between all their assets to kind of work out what their risk was. Well, they thought they were massaging big data. Did they get it right? I guess history has now shown that they didn't. So you've got to think about things. You shouldn't always fight last year's battle again, because you're going to get it wrong. So the human element is always important. I mean, I guess one of the things that I've seen in kind of practical big data is that the last mile processing is important. What I mean by that is what the human brain does in terms of interpreting things. There's one of the companies I looked at when we were looking at an investment target was a Dutch company that turns basically big data sets, puts them into a GPU, and then allows you to visualize in real time and to look for anomalies that the eye can detect, but it's difficult to write kind of rules for and for systems to try and do it. Palantir and people like that try and do it, but this way you're using the visual cortex to try and find something that was unusual. So I think the human can play an interesting role in trying to find things that are different. I mean, we do have quite a lot of processing power in our heads. So.
And are we seeing a trend? Are we aware that we need to keep a human element in the decision making, or do we see a trend towards data-driven decisions?
I think at the moment we still need to convince people to take data into account. I think that's the battle at the moment, and we mustn't forget the big picture. But at the moment the battle is, by the way, if you look at what you can really understand about the world around you in a fully quantified and reasoned way, then you can then you will make less mistakes. So at the moment, I think that's still the main battle we're fighting.
And we haven't mentioned privacy as a concern yet. How big of an issue is privacy in the data space, Ulrich?
Always. I mean, all the companies care about it. It's something everybody brings up in any meeting you bring up with any customer, what is going to do happening with my data, where will my data be stored, what will other people do with my data, or can other people access my data? And this really governs quite a bit of discussion in the whole process to set up where do you want the data being processed, how do you want it shipped. For example, we don't rely on any cloud-based services, so we can guarantee that the data is not really going anywhere except for a secure point-to-point connection. And even if you're really paranoid, you could even do that. If you don't need a real-time application, you can ship data on hard disk, as you mentioned before. If you're really paranoid, you can do that, or you run the service on premises. But that's sort of only the data between the client and us as a predictive service provider. There's also the data from the customer themselves. Each time you use a loyalty card, a Tesco Club card or a Nectar card and the likes, you need to be aware that you hand over, by using the card, you hand over personal information to your supermarket chain or to any company using loyalty data. And there, as a customer, you need to be aware of that you do that. And as a company, you need to be aware of that your clients have a right to privacy, as was discussed in the keynote. And again, there you need to find a balance of what brings really benefit to your potential business and what are ways you don't want to go and explore, or where do you want to stop.
Gerald.
I guess because one of the interesting things about privacy is I think most people seem to be relatively comfortable with when a computer knows things, but as soon as it leaks out and a human can know it or write a story about it, then it becomes more problematic. So the fact that Google is pushing me ads based on my emails doesn't particularly upset me, but I guess if somebody was looking at my emails, I would start to get sensitive. So that's kind of an interesting qualitative. But yes, privacy should be respected.
And do we have larger risks when we bring personal data and additional data into play? Because you can end up knowing so much more about a person when you're combining different data sets.
Well, most of our customers want to have this fabled 360-degree views of their customers. Whether that's desirable from the end customer perspective is a different question. But it's certainly, you could argue it brings advantages to the end customer because you will only get the ads that you may actually be interested in. But then the question is, do I really only want the ads that I actually am most likely to be interested in? I don't necessarily want to see them on a computer screen in front of me. So there's a certain element of judgment involved as to how far you want to go and how far your customers will allow you emotionally to go.
And for the most part, people seem okay if it provides a more relevant service?
I think that people are more willing to take the trade-off in certain cultures than in others.
Like which ones?
In the US, people give up their privacy, or whatever you want to call it, willy-nilly, whereas Europeans seem to have this strange reluctance to give up everything about them to third parties who may do whatever. So at the end of the day, there's no such thing as a free lunch. And at Google and Facebook and LinkedIn give their services for free. So at some point we need to wonder, surely it can't be for free. And therefore, what am I trading in against that kind of apparently free service?
So we've talked a lot about some of the different issues and ways that that people are handling data, but we haven't actually talked about some of the practical applications, the interesting things that people are using it for. I think, Ulrich, when you presented yourself, you mentioned 2 ways that you are currently working with customers to provide, predictive services. Do you want to go into a little bit more detail about what they're using data for?
Of course. We are one of the major things we do is a sales forecast. For example, for supermarkets and fresh produce, it helps a lot if you know on any given day how many products will be sold in any given store. So that really actually helps all sides. If you get this forecast right, the customers will no longer face an empty shelf, but you also, as a supermarket, can optimize your replenishment process and your logistics chain. So that you only put enough on the shelves, but not too much, right? Especially with perishable food, you have the issue that if you put too much on the shelf, you need to write it off, and whereas you need to throw away the food afterwards. So this is an area which is very very sought after in the market.
And what kind of data is used to develop that knowledge?
That's mainly using the sales data from the supermarket chain we're working with. So we have historic data from 2 or 3 years back for any given store, what they sell on any given day. You can do it in part of the day as well. There are some articles which are weather dependent. For example, in Germany, it's barbecue, everything to do with barbecue. I guess in England you do barbecue all the time. It's not proper barbecue if you don't get rained on. But in Germany, it clearly correlates with the weather, so we take in weather information as well, and there's seasonal information like Christmas or Easter. For example, Easter moves around the year, so if you're building up to Easter, that goes into a predictive part as well as to bank holidays, this, that, and the other. They all have a predictive element to it. They have a characteristic behavior which you need to take into account. Another area we're working with is the fashion industry, so 50% of the company is held by the Otto Group, which is, after Amazon, the second largest internet-based retailer in Germany and Europe. And they use it to do forecasts what will be sold in fashion items the next season. And there you have the additional twist that you only have one shot. Right? The garments need to be manufactured in Asia and be shipped back, and that is a lengthy process. So if you mid-season find out that, I don't know, yellow ties are what sells best, and you haven't foreseen that properly, you either have not enough on your shelf or you have too much. The other thing we do is going more into financial services. FIT, the original company, used to run a hedge fund with it. We've done a risk analysis for a car insurance company and see what are the actual customer behavior, how does it match the assumed risk structure. If you build an insurance tariff, you make some assumptions about your clients to come to a pricing, and if you analyze what actually the claims say, and you can optimize the tariff, and so lower the price for most of the customers and identify those who really, for example, drive recklessly.
Great. So those are some terrific examples of how people are using it to verify that their inventory will be sold. Do we have other innovative examples of how big data is being used currently, or how we think it will be used in the future, Michael?
Well, there's all the sort of customer-facing stuff that we've just discussed, but I don't know, maybe something that is sort of a little bit off the beaten track, and maybe I find easier to relate to than always selling to people over and over again, which is kind of the sad fact around our industry, that we take the cleverest people out of the best university courses, and all we try and make them do is make other people click ads on web pages or sell more stuff. Obviously there's lots of examples like that, which is how we actually earn our living, of course. But at the end of the day, there are some, every now and then you get other kind of pieces of work that sort of tickle your interest in a different way, and they're not necessarily always related to security and all these kind of things. So one of my favorite recent assignments was for a car maker, which obviously sounds maybe not so promising right from the start. But they've taken the point of view that a car these days is a metal box that drives software around. And the differentiation around the car is in the software, and it runs the valves on the engine, and it does all the things on the interior. And one of the items of software that they asked us to look at was the navigation system. And they thought, at the moment you have these two extremes in the navigation system. You look at maps, and you look at trying to get from A to B, and you take average speeds on certain types of road to try and predict what kind of road will get you there fastest. But it's just average speeds. It doesn't matter whether that road is in Bristol or in Manchester or in London or in Cambridge. You're taking the same average speed for that particular inner city road. And and on the other extreme, you have real-time information. You have traffic jam information or accident information coming out of various government services that you can link your apps to, or you have things like Waze. But there's nothing in between. And what they've asked us to do was, move us beyond the average. And what we've built was a prediction model that predicts in that case, it was restrained to Germany, which probably indicates sort of narrows the field of potential manufacturers. But we predicted for every German road what the traffic density and average speed would be on any given day, on any given time of that day. And there's obviously a whole bunch of mathematical techniques that you bring to bear on that. And that's sort of amazingly exciting and interesting sort of insights that you can get that go beyond just selling stuff to people.
Gerald, you must also be seeing some really innovative.
Well, there's one particular issue that I think almost everybody has in the world, and that is, again, the information overload. This is a practical big data problem for us at Bloomberg, and that is giving people the information they want. I think we currently scrape about 200,000 websites, plus we have our own journalists and feeds from other news organizations. And you could imagine that generates quite a lot of content. And the big issue there is you only want to give somebody something that is what we call novel to them. So we're very interested in novelty detection. But you'd think, well, maybe that's possible to do now. Yes, you can do it through machine learning. We have a big machine learning group that's focused on that. But then you realize you've got to do it quite quickly. Because what is the price impact, the price to time impact of a news story now? It's 3 seconds between the publication of a news story and when it affects a stock price. So that means that we have to do novelty detection on this large stream of data that's hitting us and be able to give it to that person and know that they haven't read something similar before, based on not the same story, but the similar content. So that's an example where which we hopefully later this year we're going to be able to bring something out. Another one is practically, which we've done for a few years, is how do you deal with emails? Some of our customers get 38,000 emails a day. That's quite a lot of emails. And how do you deal with getting information out of that? Now, it turns out a lot of those emails have just got prices in them, so you then build up systems that will kind of work out what the prices are and strip them out and give them to those people. And a lot of it is, sadly, turning sort of unstructured stuff into structured stuff and then correlating it down and putting it in traditional systems. And I guess one of the common themes I've seen is that for startups, a lot of these new techniques are relatively simple to implement. For mature businesses, putting in big data into all their systems is a phenomenally complicated thing. And like any big project, generally, most of the time it's probably going to fail because it takes so long to do the thing. And there's so many interconnects in a business. God knows how many databases that we have at Bloomberg. We still had to hire Fortran programmers because we started in 1982 and we built some of our core code in Fortran. So to interface all these systems and to get them into some big data thing so it'll actually make some sense is really tough for kind of mature businesses unless you take specific individual problems you're trying to solve. I think those are some of the ones that we're kind of worrying about at the moment. There's probably some others.
Great. Well, on that note, I'd like to go to questions. If we could have a quick round of applause for our speakers. If you have a question, if you'll please raise your hand, we have a microphone that can come around to you. And just make sure that it is a question.
Hi there. I wonder whether there's a parallel with big data to the world of open innovation. You know, open innovation is this idea that you're not going to have in your organization all the IP that you need, and so alongside R&D you buy some in, and maybe you've invented something that you don't need, so you sell that off. Is there a world of data trading coming where I've got some information that added to your information would make your operation slicker, and so we do a trade?
I see Michael shaking his head.
No, actually, it's sort of, I don't know which way I'm shaking, actually. Because there is a world of data trading that is out there at the moment, but it is very dodgy. So the data that is being traded about all of us at the moment is not necessarily the kind of things that we want to have out. But it enables some organizations to, again, go back to this 360-degree view of the kind of people they're dealing with. I think that the thinking is absolutely spot on. You know, there's so much complementarity, and that if you combine data assets and if you have the permission of your customers or users or whatever it is to have this combination happen, I think there could be enormous value that people could gain out of that.
Do we have other opinions?
Yeah, actually, I think I sort of agree with it. And there's actually a company in London called Import.io that at the moment allows you to build quick, easy scrapers so you can go and get stuff from lots of websites and then continually import it into whatever you want to do. Now that implies that the stuff is free. And one of their predictions is eventually people who put stuff on their website, whether it's Gap putting the price of a pair of jeans up there or something like that will have a value, and therefore at some point they'll start to kind of try and find ways to kind of monetize the fact they're putting out some value into the world from letting their prices be seen by people. So somebody else taking Gap's prices and comparing it to River Island's prices, somebody might start making some money out of that or think they could sell that data set. But on the other hand, we also have a $500 million business of selling data to our customers. So in some ways, we like that.
Well, maybe to pick up on your first example, right? One project we're trying to get involved in is dynamic pricing, where you also harvest these prices of competitors, for example. But also what we found is you can do that, but it might actually be easier to buy the information from dedicated portals who do that for you. So there is a market, I think, for this, and I guess data is becoming more of a resource than it has been before. We have well-established business models like Bloomberg. Also, weather information is being available since quite a while to be just bought, and I think data is becoming more. It's more of a perception that you can do this, and it becomes a resource you can sell and harvest.
Hope that answers the question. Do we have any other questions in the room?
I think Gerald mentioned earlier that machine learning has a tendency to look backwards rather than forwards. I wondered whether the panel thinks that's a fundamental limitation of using machine learning rather than insight, or it can be good around.
Well, our company is entirely based on machine learning in a sense. So we use all of machine learning techniques to combine data and draw insights from it. And what we do is just predictive into the future. So that might be a day. We also have projects running which predict into a year into the future. So for one particular drugstore chain in Germany, we give them the revenue per store already a year in advance, and they use it for personnel planning purposes. So we already told them what will happen next Christmas.
There's always a business in selling what's going to happen in the future. And sort of Bloomberg is in that business, and many other companies. And throughout history, as I mentioned earlier, people believing in technical analysis. When two moving averages crosses, that's going to tell you something about what's going to happen in the future. So all of these things basically come down to other shortcuts to understanding behavioral analysis of individuals and large populations of people. I guess we're going to get better at it, and then something will screw it up again.
So machine learning is actually inherently forward-looking, with the slight limitation that we only have data on what has already happened. So there's ways to overcome that, and the only way to overcome that is to always ensure that the data sets from which you learn and over which you test are updated on a regular basis. So using last year's data to predict next year's sales is probably not a terribly good idea. You want to have a way to keep your machine learning models alive and feed them, have them train on new data sets. And the other thing, of course, on machine learning is that algorithms change. So you need to, a good practitioner in machine learning keeps both the limitations of their data as well as the limitations of the algorithms in mind. At the end of the day, I think Ulrich and I have sort of the word data science in our job title in one way or another. And it's actually a great term, and it obviously contains the word data, which is good, because that's what we're working on. But it also contains the word science. And therefore we're not data engineers. We are scientists, and we are expected to, therefore, first and foremost, not deliver outcomes, but question the way we deliver the outcomes and question what we say. Almost is more important than what we're actually saying. So it's the science aspect, I think, is a very important part in this. And whoever takes a machine learning model and blindly applies it will fail in the same way as the person who will never use machine learning.
We have another question in the back.
Hello. I think it was Michael who was talking about the statistics and data going towards like more and more automated decision making. And my question is that, in your opinion, not just to Michael but the whole panel, that how far can it go, and how trustworthy it is when it still ties back to statistical principles which can have serious faults. My favorite example is always that if someone takes a gun and I shoot there and shoot there, statistically I kill you. So how far can it go?
So, do you want me to start? So at the moment, I think we're in a position where it needs to go a lot further. A lot further. So if to pick up with JP's medical analogies, but hopefully not quite as gory as his stories. If I go to a GP and I want, with some kind of ailment, and I want to have some kind of medication or some kind of treatment or something like that, I want that decision being made on as rational a basis as possible and not impeded by the limited mindset that my individual GP may have. Of course, you can go the other extreme and have all decision making being automated, and one day we may actually face that problem, and hopefully we will. But we're still very far away from that. At the moment, I think all our techniques can greatly enlighten and improve the way we go about our daily lives. Be that in a sort of work environment, and the way we interact with other people, even I think in our personal lives. I think all these things about quantified self and all this kind of, probably a bit funny having that being said by somebody who's clearly overweight. So I think there's great advantages we can take out of statistical analyses and predictions that will not be exhausted for a long, long time. But one day, for sure, as in the previous answer, at the end of the day, we're scientists. And any kind of blind application is going to be about as futile as not having the statistical analysis in the first place.
I guess I would fully agree with you and hit it in the same spot. I mean, we call ourselves data scientists now these days, and we do it for a reason, because now that we have the data, we can actually do hypothesis testing to data. We can say, if this effect is real, or is this effect real in the data, or is this just a statistical fluctuation? And if this effect you want to test is real, what's the statistical significance of it? You can actually quantify, and you can say, the effect is probably there, but in the given data set I have, I can only pay like a 5 sigma significance to it. Then you would say it's definitely there, but you can also say it's a 2 sigma significance or a 3 sigma significance. Then you can say, well, it's probably in the data. We're not quite sure. It's something to watch out. Or we need more analysis to be really sure what's in the data. And this, I think, is what big data will allow us in the future, or does it now, and will more so in the future allow us to really ask questions to the data and do hypothesis testing and draw scientifically sound conclusions from it. Whereas in the past, you've done reports in classical BI and so on, and try to understand why something has happened. But now you can actually turn it around and use all the statistical tools you've learned at university and in the field, and really make an analysis of it and really quantify if some effect is in the data or not.
I guess all these things you're giving probabilities to things. If I'm probably happy for Amazon, thanks to its techniques, to what it's known about me, to automatically generate my weekly grocery shopping. I wouldn't necessarily trust something today to drive my car to the station because the risks are probably different in those kind of ways. So it depends very much on the risk, because you can never predict completely the future. Some butterfly flaps its wings in the Amazon and everything goes wrong. And therefore, these are all statistical. So the human gets important when the risk goes up, I guess. If the risk is lower, then I think these techniques are relevant today.
Better tell Google about that car comment.
Yeah.
Do we have any other questions? Cedric, we're going to make you run. I'm kidding. We'll wait for you.
Hi. So you talked about the big data as in a sort of benign monitoring sense, but through the decisions there's a feedback, and that feedback is becoming increasingly fast. What do you see as the issues around stabilities of system? We saw some of that in the financial markets where, big data was feeding back into financial markets. But other things, your buying choices depend, as JP said, if there's green pickup trucks on the parking lot, you buy the green pickup trucks. It's not just a question of that. So how do you see that feedback really as this sort of recursive thing affecting the way this is developed?
Shall I start?
Sure.
Sorry. I think it's a great question, actually. Like all the questions so far, I should have said it early on. They were all great questions. Thank you. I think it's a very important question because in my sort of simplistic mapping and drive time example early on, if it's sort of a quantum mechanics type effect where the very fact that you're observing the system, you're changing the system. By the very fact that you're providing better information about current traffic flows, the only reason why you want to do it is to affect future traffic flows. So the effect, that the sort of strange recursive effect that you've just described absolutely exists. I think at the moment, most of them are marginal, but with a potential to become significant. And therefore, it comes back to your learning and your testing data sets and your ability to keep your model alive with steadily improving learning and testing data sets that hopefully will capture as the recursion happens. Hopefully it doesn't sort of catch you out because it happens too fast. As the recursion happens, you will need to keep your learning model alive by feeding it new data and testing it on the new data. So it's sort of the race against the machine type argument, and it's once you've started the race, you have no choice but to keep on running faster.
Yeah, well, I guess that back testing and then continual improvement in a system is essential. So you come up with a new model that's been based on the new data, and then you have to feed it back and see was it any better at getting to where we are today. So I guess the feedback loop is important.
Yeah, I guess in all of this, you sort of assume that you're steadily moving to the global optimum in this kind of thing. So, for example, the news feed, there's apps which will select news you're likely to be interested in on, and then if you only read what this app's presenting to you, you always get a very selective view of what's going to happen in the world. I think it's also important then you say I'll test outside where I am and see if the data behaves completely different in a different realm, and continue to challenge yourself as well in this data science game and say, if I can collect data which is far away from where I am, in the past I've discarded it, has something changed in the world? Is there new data, is there new dynamics evolving which here is good but there would be even better, but if I don't look anywhere else but where I am, I'm likely to miss it.
We tend to check whether our clustering changes. Yeah, that's always a good indication. If you have a view of, if your clustering algorithm gives similar results as you go along, you're probably okay. All of a sudden, when they change, and particularly when you change drastically, or when you get many more outliers than you used to, some things happen. You need to keep an eye open what's going on. I think high frequency. Sorry,
go ahead.
I keep on talking until you interrupt me.
Go for it.
I think high frequency trading is an interesting one because I think you spoke about the optimum. I think high frequency trading, when you have sort of the 30 to 40 millisecond response time, I think they are very close to the optimum of what they can do within the kind of technologies that they have available at the moment. And the question is, how much are they exposed to recursion effects? And I think it's a major effect for them. And I think they've gone the other way in that now they're trying to exploit the recursive effects. So, but they're bankers, so just think in different ways anyway.
I think we have time for one more question.
Thank you. So it all seems that there are two steps around big data. The step number one is the collection of the data as much as possible. And the second step is to make smart decisions as much as possible. Now, today, different firms in the world have a lot of access and they manage to collect a lot of data already, and some of the firms can make smart decisions, a lot of smart decisions already. But in your view, where is the biggest potential area in the next 3 to 5 years where different or more kind of data is collected, but it's not yet today? And followed by the second question, on the top of that, what type of smartest decision that can be derived on the top of that kind of big data? Thanks.
Wow.
That's an excellent question. Excellent question. We are in Cambridge. Hooray.
Go ahead.
Thank you. A brilliant question. And so my personal point of view for the single most important area that will, over the next few years, be impacted by this sort of big data thing is healthcare. And obviously, 20 years ago, we all got excited about this sort of about genomics. And nowadays, we know that just knowing what your DNA looks like and what the structure is and what sits where actually gives you nothing, or almost nothing. It's not true. Sorry, it gives you very little. It gives you some insight into some important diseases, but it hasn't led to the revolution that we all expected. Because the revolution comes when you combine a completely different set of data, and that is all around you, not as being made up out of DNA, but behaving as a social individual with all the great things that you do, eating vegetables and doing exercise, and all the things that are not quite so great, all your lifestyle choices, the socioeconomic environment in which you grow up and where you live, all these kind of factors, at the moment, they are just too varied and too soft to be included in analysis. And in my personal humble opinion, I think that is something that will change over the next 10, 20, 30 years, when we're starting to be able to correlate health outcomes, not just on the basis of genomics, but on the combination of genomics and social data. That will really change our lives. Our children, our grandchildren, probably more importantly, will be greatly impacted by that, and will look at the way they lead their lives and how that relates to health in a completely different way from how we see it.
Does everybody think it's healthcare?
I think so, because I guess we heard about the Internet of Things, but as a way of improving human beings' lives, taking kind of large data sets with other science, life sciences, and putting them together, I think will have much more of an impact on human beings around the world than whether you can switch a light on somewhere, which will, no doubt, most of the time probably not work. Certainly, every time I've tried to use technology in my house, it has failed, including Wi-Fi. Actually, my Wi-Fi failed here today as well. But I think that's an example in terms of improving life, because understanding more about what human beings do and are will probably get the most benefit for us.
Ulrich, I guess we'll finish with your opinion.
Yeah, I guess I agree. There's now an emerging trend. It's a personalized medicine based on your genome scan and so on. You can tailor the medicine towards your specific needs rather than apply something which works for a lot of people but maybe not for you. But also, I think the Internet of Things is rather in its infancy. It's maybe not so much home automation, but it's having a huge impact on production plants, be it steel, cars, or whatsoever. If you bring together a lot of the machines building, whatever, the cars or producing steel, if you put all that together, you can have a huge impact on the business model themselves by, for example, in the steel industry, deciding early on in the process what will be the quality of the final product. Will it be fit to construct bridges or skyscrapers, or will it be in the low end? Well, the lowest end, I guess, will be dustbins. And the earliest on, you can decide. You can also base your business or your construction plans on this. But this is in the very beginning of this Internet of Things. So I guess in the next few years, we'll have a much clearer picture what will happen there.
Wonderful. Well, thank you so much. Thank you for being a great audience. Can we have a round of applause, please?